afternoon. My name is Hanyun Lee from Hanyang University in Korea. So today I will present my paper titled AR-based multisensory human interaction in rehabilitation. So my research focused on how we improve user experience in rehabilitation exercise using augmented reality. And I'll talk about how we use multisensory interaction to make rehabilitation more engaging and immersive. So here's an outline of my presentation. First, I'll briefly introduce how AR is currently used in rehabilitation. Then I'll explain the main contributions of our research, followed by how we implemented our AR system. Finally, I'll show the result of our user test and share our key findings before wrapping up. AR technology is already being widely used in rehabilitation. For example, a Penumbra Real Y series use sensor to support various body exercise through AR. Stroll use AR glasses to provide visual cues that help Parkinson patients walk better. These examples clearly show that AR is becoming an important tool in healthcare and in rehabilitation. However, current AR systems have some limitation. In our study, we identified two main challenges we wanted to solve. First, we needed more realistic interaction with virtual objects to increase user immersion. Second, we wanted to encourage users to voluntarily participate and keep exercising regularly. To overcome these challenges, we developed an AR rehabilitation game specifically designed for upper limb exercise. The idea is simple. By playing the game, users naturally perform rehabilitation exercise. The game has two main stages, the game description stage and the gameplay stage. In the game description stage, we provide clear instructions and demonstration using virtual simulations, making sure even first-time users can easily understand how to play. Once users understand the game, they move on to the gameplay stage. In the gameplay stage, users perform exercise by interacting directly with virtual objects. Specifically, users feed a virtual bird by using their hands to control a virtual branch and a caterpillar. As you see in the video, user must position the branch inside two transparent spheres at the top. If they hold the branch correctly, the bird successfully eats the caterpillar. But if not, the bird missed the caterpillar like that. This game naturally guides users to perform correct movements and gives immediate feedback. We include four main design elements: hand tracking AI, real-time feedback, multi-sensory interface, and the last one is gamification. To summarize clearly, we focused on three main points. First, we improved immersion by using multi-sensory interaction in our AR rehabilitation game. Second, we added gamification to make repetitive exercise interesting and enjoyable. The last is we conducted user tests with 35 people to identify problems, make improvements, and enhance the overall user experience. Now I'll explain our multi-sensory interaction design in more detail. First, what does multi-sensory mean exactly? Multi-sensory interaction simply means using multiple senses like vision, hearing, and touch to make virtual interactions feel more natural and realistic. In everyday life, we naturally use all these senses together when we interact with real objects. To achieve the same realistic feeling in AR, we also need to use multiple senses. We successfully integrated multisensory elements into our game. This table shows examples separated into visual, auditory, and haptic categories. For example, we used a highlight effect on the branch handle to clearly show user where to grab. We also created realistic bird animation to make virtual interaction feel natural. User can immediately see if they're performing the exercise correctly, because the caterpillar disappears when they do it right. For sound, we added effects like push, chirp, and click sounds and also included voice instructions to guide user clearly. Next, I'll talk specifically about the haptic illusion we used. Because our system used hand tracking without physical controllers, we can't provide actual touch sensations. Instead, we use visual and sound cues to simulate the feeling of touch. For example, when users press the virtual button, the button visually moves slightly, giving users the impression they are pressing something real. Similarly, we made the virtual branch change from transparent to opaque when users grab it, enhancing the feeling of touch. These techniques together significantly improve immersion when interacting with virtual objects. Other important aspect was preventing user from getting bored with repetitive exercise. To solve this, we turned exercise into a fun game. The game naturally encouraged users to perform correct movements, helping them intuitively learn and maintain proper exercise techniques. Now I'll explain our user test scenario. We continuously improve our multi-sensor interface based on user feedback. We test our system with 35 participants, 14 design professionals, and 21 design students using HoloLens 2. Participants play the game from the instruction stage through the gameplay stage, experiencing all multi-sensory features. Afterwards, we interviewed them to collect detailed feedback. This means we needed to make our virtual objects more opaque. We added graphic contrast effect to create a stronger sense of opacity. Based on the feedback, we made the graphics opaque when users interact with the object, helping them focus on the interaction. On the other hand, when not interacting, the object became translucent so they wouldn't block the user's surrounding view. If you look at the table 2, you can see that most participants, despite being new to AR, still gave positive feedback about the clarity of the graphics and how easy it was to interact with the virtual object. The final subject evaluates the overall user experience. Most participants said it was hard to perform exercise using virtual interaction alone, and many agreed that voice guidance was necessary. Also, many users request additional special effects during interactions, especially when grabbing objects. These findings strongly support our multi-sensory approach, clearly demonstrating its importance for creating an immersive and intuitive AR rehabilitation experience. To explain the overall process of our findings, we started with the initial game design and conducted user testing. Based on the feedback, we added three key features: contrast adjust visual graphics, emphasize interaction area, and the last one is voice guidance and sensory feedback. This update led to revised version of the interface. Through in-depth interviews, we confirmed that these changes create a better and more user-friendly interface. And I'll show you our final demonstration video of the AR-based rehabilitation game.
분홍색 부분을 잡아 운동을 시작해주세요.
I think it's a little buffering here. Oh. In the video, you'll see transparency change clear showing when users are grabbing or releasing virtual objects. You can also notice the caterpillar disappearing when the movement is correct. And you'll hear a push sound effect when user move virtual branch quickly. In the left image, in the final FGI, we found that the updated multi-sensor interface was more user-friendly and helped increase user sense of immersion. In conclusion, we successfully improved user immersion by using integrated multi-sensor feedback, which was confirmed through user testing. We continuously improve our AR rehabilitation game based on user feedback, significantly enhancing the user experience. Finally, I briefly mention limitation and future improvements. Our study mainly focused on subjective user feedback regarding immersion. Future research should include objective, measurable data to evaluate immersion clearly. Also, our system currently shows only whether exercises are done correctly. In the future, we plan to implement an AI-based human pose estimation system to precise evaluate users' posture and movement. Thank you very much for your attention, and feel free to ask any question. Yeah.
Okay. Please.
That is a cool project. That's something that I like your project. It's the kind of thing that I've wanted to start working with for a long time. As you might have guessed from the cane, I've a little more familiarity with physical therapy than I would like to. And I was wondering, had you considered the option of having variable levels of challenge within the game? Because a lot of the time in physical therapy, when you first start out, a successful exercise might just be lifting your hand at all, as opposed to the full range of motion exercise. So having that variation might be really useful for allowing subjects to move through the healing process so that it adapts to their expected level of physical capabilities. It also might be worth saving the pose data, even if you're not using AI, because from a physical therapy perspective, you don't necessarily need AI, but a good physical therapist can actually look at the smoothness of the motion or the actual exhibited range of motion where difficulty creeps in, and really use that to tailor the next steps of therapy. So this could be a home device that they take home, work with, bring the data back to the therapist, and really get a much richer therapeutic environment from.
Thank you for your question. I think there's a really good point. That's because I think there's a little limitation in our paper because we have to evaluate the procedure when they exercise with our AR rehabilitation game. But in our paper, we consider the user-friendly interface for exercise their own self.
Yeah.
So we provide the direction to make the interface for home healthcare and rehabilitation fields. So I think your point is very good. For afterward, I implement the level of the game, and then I evaluate the procedure of the rehabilitations. So thank you for teaching the good point.
No, thank you for the front of that, because I will also tell you, physical therapy is one of the most painfully tedious things you'll ever do. So having an entertaining app to take home would have made my life a lot easier at different points.
I know.
Okay. Please.
So you mentioned that you tested your game on HoloLens 2, right?
Yeah.
Did you have like field of view challenges that comes also with AR and MR devices? As we know that the big challenge for MR developing an AR, just like having this limited window to see your augmented reality world. Yeah. Other question that, as you already mentioned, that you are developing for MR or HoloLens. So can you consider this as your approach to MR more than AR? Consider the multisensory and the type of display you are using?
The first question I answered in the first. I think there's also something limitation in HoloLens 2 because I have the HoloLens 2 device in my home. So the HoloLens 2 has a very small field of view, I think. So that encourages the user to downgrade the immersion. So that's kind of like limitation in the device limitation. And the second question is. Can you explain?
Yeah, because you are introducing augmented virtuality application, but as you already approached multisensory and mixed reality, that's it. So can you consider that you are going forward to the mixed reality application or mixed reality experiences? Can you say that?
I think we started the AR field, but in the future we have to move on to the MR and VR and other things. We have to move on the field to.
Because I think you already stepped inside this
fields.
area. You're just there. You need to keep moving.
Yeah, I have to keep moving.
Thank you.
Thank you so much.
As a co-author,
I'd like to add one comment about your question. Actually, we are developing real virtual interaction system. It means interactive real world. The real world responds to the virtual world. Yeah, that's we are developing now. Yeah.
Do you hope to eventually put actual haptics into it? Because that would be super useful in physical therapy to have that kind of real-time feedback of you're doing a proper squat versus you've favored the one leg that works, so you really defeated the exercise's purpose, for example.
Okay. So, thank you for the very good comments.
Thank you.
Wonderful project.